Well, let's look at this problem. It's not truly a linear equation, but it is a rational equation which will ultimately turn into a linear equation. But let's read through it. 1 divided by x minus 5 minus 2 over x plus 2 equals 3x over x squared minus 3x minus 10. All right, it's not a linear equation because my x's appear in the denominator. In fact, there's even an x squared term here, which kind of added a little bonus to this problem. All right, so, but I'm going to use the same ideas in the last problem. Going to clear the fractions by finding the common denominator, or at least the least common denominator, and multiply every term by that common denominator. And when you do that, that will cancel the denominators and will leave you with a nice problem with no fractions in it. At least no fractions in it. All right, so first I need to factor, and when we factor this, it's going to end up being x minus 5 times x plus 2, so it's going to be easy to verify that. I'm going to rewrite this and kind of spread out and make some room. So I have 1 over x minus 5 minus 2 over x plus 2 equals 3x over x minus 5 x plus 2. So that, you can check that this is factors correctly by multiplying these binomials back. And fortunately, it's the same consists of factors that match what I have over here. And if it didn't, this problem would be considerably harder and more complicated. So what is my common denominator? You know, the least common denominator is what you get when you pick up each different factor. And to be a little more technical, you actually have to pick up the highest degree, the highest exponent of each different factor. Well, there's only 2 different factors here, x minus 5, x plus 2. And so I'm going to multiply every term by x minus 5, x plus 2. So I'll write these in. I like to show this step, because now you can see everything cancel off very nicely here. This x minus 5 cancels that x minus 5. Here the x plus 2 cancels. And here both factors cancel. So that eliminated our fractions. You know, the denominators have been eliminated, but just ones now, and I don't need to write the ones. I'm dividing by 1, I don't need to even think about it. So I'm going to recopy this. This is 1 times x plus 2, so I know that's just x plus 2. And here I've got minus 2, parentheses x minus 5, equals to 3x. All right, another big red flag here. Students really screw up this problem, this type of problem, a lot. And it's going to be right here, because what should this term be? I have minus 2 times minus 5. When I distribute, I should get a plus 10. All right, in fact, let's go ahead and distribute. And so to simplify this, I have to distribute through the parentheses. So I have x plus 2 minus 2x, and then plus 10 equals 3x. So let me point out that distribution step again. So right here, that's the mistake. Okay, now I can give this problem, and this is actually comes from our intermediate algebra course, this type of problem. So this really is a review. But in intermediate algebra, about half the students will screw this up, right here. Now if half of them screw that up, it means about half of you might screw it up too. Okay, so pay close attention. You know, don't skip too many steps. A lot of students like to, I guess it's maybe it's beneath them to do a lot of writing when they do math, and so they skip steps, and you know, they'll jump from here down to here, and those are the ones that are most likely to mess up something, because I had this negative 2 times negative 5. So what will I normally see? I'll see a minus 10, or I'll see a minus 5 here. I won't see a plus 10. So again, that's one of those real common errors, and which means that you have a pretty decent chance of making that error if you're not paying big attention here to this. So, you know, use good habits. Don't skimp on writing your steps. All right, do a little bit of writing; it won't hurt you. And be careful. Look at what you're doing. You know, go a little slower. Just make sure you've copied everything correctly and have distributed correctly. You can avoid those errors. Okay, from here it's going to be pretty easy, I think, because if I combine these terms, x minus 2x is negative x. 2 plus 10 is 12. Plus 12 equals 3x. And then if I add x to both sides, and I need more room, so let me do a little racing up here. I'm going to get the x's cancel. 12 equals to 4x. And now I'm going to divide by 4. So 3 equals to x. And again, let's write it like we speak. X equals to 3. There we go. Now you don't have to circle your answer every time. I kind of like to sometimes, just to emphasize what the answer is. And if you tend to be pretty sloppy with your work and you have a page full of calculations, sometimes it's hard for me to find answers. So it's not a bad idea to circle an answer if you're one of those type of people. If you have stuff all over your paper, then be nice to let your grader know what your answer is. X equals 3. All right, and it would not be a big deal to test to check this. You know, plug 3 in here and work it out. Not a big deal. But there we go. That's the problem. And again, the motif here, or the idea, was to first we factored the denominators. Well, this one needed factoring. And then we picked up the common denominator, the least common denominator, and multiplied each term. And that allowed us to cancel. And then from there we can turn into a more ordinary looking equation and finish solving. There we go. Now, there's a problem with some of these problems, and so we're going to come up on that here in a minute, and I'll show you where things could go wrong on this.